Hey everybody, today we'll do another quick video, and today we will do a quick video on converting the impedance from a rectangular form to a polar form, right? So we are asked, is that find the impedance of the following circuit, express your answer in polar form, right? So basically we have a voltage source in the circuit, and we have 5 ohms, we have a 7J, we have another 10 ohms, and we have a minus J5, 5J or J5, whatever you want to call it. This is a capacitor, and this is an inductor, right? Now, when we do the impedance, we get rid of the voltage source and just write it like this. So we find the impedance, we open the circuit, and we just have the element that have the impedance, right? So when you measure any type of resistance in your circuit, make sure you disconnect the power. All right, so or you measure the continuity in the wire, also make sure that there is no power on it, right? Okay, so in this case, we know that we have this, right? So now we know that this is in series, so we can add this and that, and add this and this, right? So they are already in the polar, in the rectangular form. We can add them. We're looking for the polar form. So with that being said, let's get started. So let's add this, and this is going to be 5 ohms plus 10 ohms is going to be 15 ohms. And we have 7J minus, or plus, you can say plus negative 5J is going to be equal to plus 2J. Now, if you look at this, some books write like this. So let's do it like this. I think. Just do it J2, J, right? So, okay, so with that being said, we need to find the magnitude of that, right? We're looking for the magnitude, and then we're looking for some type of angle. So what I'm trying to say is the following, right? So this is, right? So let's say that we're looking for something like this. We're looking for the Z value. Actually, you know what? Do it right here. So we're looking for the C value, right? So this is 2, and this is 15. Right. So I'm looking for the Z value. Right. So with that being said, that with this mean that this is X. We call this J, Y, right? Because the imaginary part. Right? This X is right here is the J, Y part of it. Now, okay. So I'm sorry about my drawing. I am not really used to the software, so basically you get an idea, right? So, okay, so matter of fact, you don't even have to. If you don't understand the concept, you don't even have to write this to draw it. But it's a good, it's a good thing to have an understanding, right? Okay, so we're looking for the angle, and we're looking for this angle right here, which is the angle theta, right? So we're looking for this, right? So we can say that tangent of theta, right? So we can say that the angle theta is equal to the tangent inverse of sine over cosine, right? All right, so remember from pre-calc, we do 2 over 15, right? So when we take that angle, we get so we're looking for the angle. So we say, let me see if it's in degree mode. It had to be degree mode because we're doing right. So let's do this. So second tangent of 2 over 1/5 is equal to approximately 7.6 degrees. Right. Now, so we found the angle, but we need something else. We need the z, right? We need the magnitude. So to find the z value, we say that the z value is going to be equal to it's going to be equal to the square root of 15 let me see. It's going to be equal to square root of 15 square plus the square root of 2 square, which is going to be equal to the square root of 15 square is, I'm sorry. So 15 square is 225, right? 15 square is 225 plus 2 squared is 4, so it's going to be equal to 229, right? The square root of 229 is going to be equal just tiny bit more after 15. It's going to be equal to the square root of that is going to be equal to, so it's going to be equal to so that is going to be equal to the magnitude of z is going to be equal to 15.13 with an angle of 7.6 degrees. So that is the answer for that problem. So So basically, the impedance in polar is 15.13 the magnitude and with an angle of 7.6 degrees, right? So, and just to make it sure that we understand what we're doing is that when we're doing polar, we go counterclockwise in that angle, right? So maybe eventually we'll do a problem. The length of here, this triangle length, it will be in the second quadrant or third quadrant where we have negative, right? So, but we're looking for this angle, right? We're looking for the angle counterclockwise in polar coordinate system, right? So that will be the answer for this in polar coordinate. The impedance will be that, right? So, and eventually we will go from polar back to rectangular. So yeah. So that's the answer for that. Thank you for watching, and remember that over here in the Conservative Engineering Academy, we learn something every day because Jesus is good, right? Remember, Jesus is the Lord, and He is our Savior. Thank you for watching, and have a blessed day. Thank you for watching.